Alright, on popular request, I have been asked to make a video on weather coding and decoding, and this is a video on it. I hope I do a good job. For this video, I'll have to go to and fro from this screen to the weather code and decode book, so you will have to follow me as I take you to and fro. If at any point of time you are in any doubt, just pause the video, and or you can just go back and then watch what you want to. Alright, so I'll try to go slow, but let's see how I go with it. So this is the example of the coding or decoding of the weather report that you have to carry out, for example, and I'll show you how to do each one of them. It may make the video a bit long, so watch till the time you find it interesting, and then you can stop watching if you find it's too boring. Alright, let me know how you think about it. So let's start with the first one. So the first one here is the BBXX letters, that what you see. So the first one is pretty simple. If you see the BBXX, that means it's a surface report from a ship. Normally if it's from a coast station, you will see the letters AAXX or Alpha Alpha, X-ray X-ray, or AAXX, whichever you find it easy to follow. The second one is are the letters ATVH, as you see in the example here, the ATVH. Now this ATVH is the call sign of the vessel. It's the signal letters of the vessel, and I'll show you how I'm deciding all this. I'll go into the weather code and show you, but I want to make it a minimum the number of times I go in and out of the weather code. So I'll probably wait till I go to the next entry, and then I'll show you all the three that I've talked about. Alright, so the third one here basically are the numbers 1, 0, 1, 2, 3, and as you see, I have written the numbers right below the letters above. So I have written 1 below Y, 0 below Y again, then 1 below G, 2 below G, and then 3 below IW. And what this stands for is the first two numbers stand for the GMT date, that is, it's the 10th, and the next two stand for the hour, which is the 1 and 2, it's 1200 hours, and the third one is the wind speed reported by force estimated in knots. Alright, now that is number 3. I'll show you how I deciphered all this. So let's go into the weather code and discuss all the three readings that I have just now shown you. So what I'll do is I'll go into the weather code book here. So you can see this is the weather code book that I've kept it ready, and you can see the first one is the you can see if it's a call sign, you can see this is the call sign here, and then it also talks about whether it's a surface report or a ship report. The third one talks about the group YYGGIW that I just now discussed, and here you can see that YY talks about the day of the month, which was 10 in our case. Then GG talked about the time of observation to the nearest star, which was 12 in our case, and that was in UTC, so this is GMT UTC time. And then IW, which was 3 in our case, indicates the wind speed. And how can you get the wind speed? You can get it from table 1. That's what the weather code book is saying. So what I'll do is I'll go into table 1, and again, like I said, it's a bit to and fro, so here it is, weather table 1. Alright, so table 1 is here, and you can see the letter number 3 is the wind speed estimated. Speed is in knots. Alright, so that's the wind force. So I'll go back and I'll show you more of the things that we see in the weather code and decode book. So then you go into number 4. Number 4, as you can see in the table, is 99408 in the example, and I have written again the numbers right below the letters. So I have written 99 below 99, and then 4 below LA, or 0 below LA, and 8 below the third LA. And what do they stand for? They stand for the position of the vessel, where the position of the vessel is 40.8 degrees, because this is 40 here, and then the third one is the decimal of a minute, and then you can see the other number 30492. The 30492 has been written here right below the letters again, right? And this stands for 49.2 degrees of longitude. So the first two numbers don't mean anything except that it is longitude and 99 is latitude. It's the last three numbers which will indicate the position of the vessel. So the first numbers are 408, which is 40.8 degrees, and in the longitude case it is 49.2, so it is 492, so it is 49.2. So you can see that this LA on top stands for latitude and the LO stands for longitude. Now I have also got my south and east here. Where did I get the south and east from? So for that I have to go back into the weather code book and I'll show you how you can determine the south and east. So if you go back to the weather code book here and again go back to this page here, that's right. So you can see here on this page the latitude and longitudes are described here in this section, and this is where I put the numbers and I got my latitudes and longitudes from. It gives me the instructions as well that the latitude is in degrees and then tenths of a minute. That is why I had 40.8. What it also tells you is the table that you have to go to determine the latitude and longitude. So how do I know whether it's south and east? Alright, so let's go into table number 2. So for that I'll go. So you can see the quadrant. Oh, if you didn't see, I'll just show it to you. You can see here table number 2 QC gives me the quadrant of the globe. So QC, the number QC, and if you go back QC in my question, QC, the number QC is 30 here, 3 here, or 30. Okay, so if you go back to the weather code book, you have to go into the table 2 to determine what does 3 stand for. So if you go into table 2 here, this is table 2, QC stands for the quadrant of the globe, and I had 3 as the quadrant. So 3 stood for south and east. That's why my latitude was south and my longitude was east. So that's how I got these values from. Alright, let me know if you didn't understand this particular point here. So you can see the QC here, QC was here, that was the quadrant, and my quadrant was number 3. So when I said the 30 doesn't stand for anything, I meant it doesn't stand for anything with the position. Your positions are the last 3 letters, and the first letter gives you the quadrant. Then I go into the 5th portion here, which is the IR, IX, HVV, and the numbers that refer to that is 41398. So these two are the position. I can put my position here. This is the day and time, right? I can put my call sign here. This stands for a vessel report. So 41398 will determine the, see again I have written the numbers right below the letters. Alright, so write 4 below IR, 1 below IX, so on and so forth. I have written the numbers right below the letters here, 41398. Now here this stands for precipitation group not sent. It's a manned station, and the group 7W, W1, W2 is included in this report. Cloud base is 200 to 3 meters above sea level, and visibility is 20 kilometers. Now where did I get all this information from? Again, I have to go back into the weather code book, and there all that explanation is given there. So let me go back there. So if you see, if you go back here on this page again, you have to go by one. That's why this video becomes a bit long here. So you can see this is the group I was talking about. So you can see the indicator for the precipitation group is table number 3. The indicator for type of station is table number 4. The height of the base of the cloud is table number 5, and the horizontal visibility at surface is table number 6. So if you go to these two tables, table number 3, 4, 5 and 6, you can get all these details from based on the numbers that you see here. Alright, so if I, for example, I'll take a couple of numbers here for you. So you can see the first number here for IR is 4, for IX is 1, right? And then we have the visibility also as 98. So what do these stand for? So if I go back here, so you can see here 4 stands for group precipitation amount not available, and that is what we put the number as. Then if you see 1 is man station included. All right, and then if I go into the visibility section here, so the cloud base is of course also included there. The visibility section, which is, sorry for that you have to now view it a bit, you have to just trust me here. So this is table number 6. I could not get it in the portrait form, I had to get it in the landscape form. So here the visibility is given as you can see is 20 kilometers, or 20 kilometers is the visibility. So you can see here the distances are given in the kilometers, and that pretty much tells you what each of the codes stands for. Alright, so you've got this 20 kilometers of distance here for the code of 9. So that's how it works. Alright, so you have to go into the relevant table and then find out the number there. So I'll keep going. Then we have the 6th digit here, which is NDDFF, and again I'm just spelling out the letters for you here. They all stand for something. So you can see I've put 6 below N, 28 below DD, and 28 below FF. So again you will have to go and find out, because one of them stands for total cloud cover, the other one stands for a wind direction, and the third one stands for wind speed estimated. So the wind speed estimated is 28 knots as I have written here, because these are the last two is wind speed. Wind direction is 280. You just get the first two numbers and you estimate is 280, otherwise it would be, you will go and see in the what it means, and then what does this 6 mean. So again go back into the weather code book, and you will see that the table number 7 provides you with all the details here. Alright, so if you go into table number 7, this is pretty much telling you what does a 6 mean, that is 6/8 of the sky is covered. What does DD mean? So 628, that was the number was 62828. So 028 or 280 degrees, you can see here is 28 means 280 degrees. So if you were wondering what 028 would mean, it would be somewhere between this code and here, 2 and 3. Alright, and then if I keep going, table number 8 is done. Table number 9, again sorry, it's again in a format that you will not be able to see, but table number 9 is giving you a Beaufort wind scale of speed. So if I say it's 28, so basically 28 is the wind speed estimated in knots of current. Alright, so this is here knots, it's about 28 here. Alright, so this is how you have to study the table. So I'll again go back and continue with my reading. So but you are getting the idea, right? So you have to go and consult the relevant tables here. Number 7 is the air temperature as the 14.3 degrees Celsius. So 14.3 is from here 143. How do I get that? Well, again go back into the weather code book, and so if you are in doubts on which table stands for what, you can see over here only it tells you everything on the first 2 pages. So I have finished with I am right now doing the weather temperature, which is 1 SNTT. So I'm somewhere here, sorry, I'm somewhere here. This is the table. So 1 is the indicator figure for this group. SN is the sign of temperature that you get from table number 10, and then last 3 digits, it gives you the air temperature in whole degrees and tenths. So if you go into table number 10, it is this table here. So SN is the sign of the temperature. 0 stands for positive and 1 stands for negative, and the last 3 TTT is dew point. Alright, so I can keep on going, but you get the idea now that whenever you see the numbers, and you have to go in order. So if you go in order, you can just have to go into the relevant table number, and that will tell you what each of them stand for. But I'll keep going as long as I can, otherwise I just don't want it to become too boring for you. So table number 8, or not table number 8, but number 8 is for the dew point temperature. It's very similar to the air temperature, where the last 3, you can see the TTT with the D stands for dew point temperature, gives you the dew point temperature, again this is for the sign, this is the indicator, and you have to go into a relevant table as well. Number 9 is your atmospheric pressure, 1008.4, where your last 4 stands for the pressure. 4 is the indicator. Again you have to go into the relevant table for that. So if you go into the very first page, it will tell you what number of table you have to go into to find out the relevant pressure, atmospheric pressure. So if you go into 4 ppp, so you can find out what the pressure stands for. Alright, should I keep going? So I'll keep going, and then number 10 in my one is 5 APPP, which is basically describing the barograph trace, where you can see that the last 3 ppp stands for the amount of pressure tendency, that is 0, 2.8 that you see here, tendency. The A here stands for characteristics of pressure tendency during the 3 hours preceding the time of observation. Number 5 is just the indicator figure. So again, if you go into the relevant table, you will find that you can get the barographic trace as well from there, and that will give you the details of the tendency of the pressure that it is showing. So you just have to go into the relevant table, find out the information from it. Then I go into 7W, W1, W2, which has the numbers 76364, where 7 is the indicator figure, 63 basically indicates the present weather, and 64 indicates the past weather. So present weather indicated by as moderate, non-freezing continuous rain, whereas past weather indicated by 64 is as rain, fog and haze. This should be fog. So again, if you go into the relevant table, if you don't know how I'm getting all these values from, you can see that over here I've got the characteristics of the barographic tendency, where these numbers tell you what the tendency is. Then here table number 12 gives me the present weather. You can see WW written here, and again you have to just go as per the number and find out what each of them stand for. If I change this table, so you can see present weather is here, it keeps going. Over here it shows you this is present weather continued, and then again if I change the table, it's still present weather, and over here, that's right, so over here table number 13 is past weather, and again you can see from the code what the past weather will be. If it is 6, what it stands for, rain, 4 is fog or thick haze. So this is how it is done. Simple, just go into the figure and it's pretty straightforward. Then I'll keep going and I go into here, which is telling you about the cloud cover. So cloud cover is 8 is the indicator figure. Then we have the amount of individual significant cloud layer, which is indicated by low cloud covering 4/8 of the sky. Then we have CL as the type of cloud, CM or type of low cloud, CM is the type of medium cloud, and CH is the type of high cloud. And that's why if you go into the numbers there, you can find out what type of low clouds are there, whether it's cumulonimbus, whether it's medium clouds or altocumulus or cumulonimbus, or if it's high clouds then it's cirrus in the form of hooks or filaments. So each of these numbers, and again when I go back into the weather code book, I'll show you again the table number, but I'll keep going, otherwise this video becomes very long and you guys will get bored. Then I go into the next section here, which indicates the course made good in the last 3 hours, where 222 is the indicator figure. DS stands for direction of resultant movement of the ship during the 3 hours preceding the time of observation, and VS stands for ship's average speed made good during the 3 hours preceding the time of observation. Each of these numbers stand for the direction, so 3 stands for southeast and 4 stands for 16 to 20 knots of speed. Again, if I go back into the tables, you can see here And table number 14 was discussing the type of cloud, where the relevant type of low cloud, where the figure would have told you. Then I want to show you a few things together, because otherwise it's just going back and forth. Table number 14 is continuing with the type of low cloud. Table number 15 is type of medium cloud that we discussed earlier. Table 16 is type of high cloud. Just go ahead to the number and you will find out. Then table number 17 is the one we were doing last, where DS is the ship's course made good during the 3 hours. So again, if you see the number here, it was number 3 in our example. So 3 is southeast, as you can see. So this was southeast. And then the speed, ship's average speed made good, was table number 18. This is VS here. And our number was it 4? It was 4. So 4 stood for 16 to 20 knots. That's how I was getting all that information from. Alright. Any point of time you don't understand something, just pause the video, go back, and you'll get an idea. Alright, then I keep going. I'm into this section here, where this stands for the sign of temperature. So O is the indicator, SN is the sign of the temperature, if it's positive or negative, and the last 3 digits gives me the temperature, and 0 is again positive. So this is C temperature, Then I go into the section here, which gives me 2 is the indicator figure, PP is the period of waves in seconds, and HH is the height of waves in units of 0.5 meters. Alright, so if I say it's 08, that means the C period is 8 seconds. But if I see 08, because it is height of waves in units of 0.5 meter, whatever you see is 08, you just half it and you will get the C height as 4 meters. So again, I'll take up these 2 tables and go back into the weather code and show you what each of them stand for. So table number 18, this is ice accretion, so you don't have to worry about that. So we haven't come to that stage yet. So this is what it is, pretty straightforward. You can see that 0 stands for positive, and 17.5 is 17.5 degrees temperature. Alright, now we come to number 16 here. So we have 302. So we have 3 DW1, and I have to explain what each of them stands for. So DW1, and DW2. So DW1 is the first swell, or direction of the first swell, and DW2 is direction of the second swell. So as you can see here, the first swell was from a direction of 0 to 0 degrees, and there was no second swell. That's why there is no information here. Then number 17 is where height of the C swell, first swell, and the height of the second swell is given. P1, P2, PW1 is the period of the first swell, and if there is a second swell, then there will be PW2, but HW1 is the height of the first swell. And because there is no second swell here, there is no PW2 or HW2. Alright, so because no second swell has been identified here, if there was a second swell identified here, there would be a PW2 here, and there would be a HW2 here as well, to identify the period and the height of the second swell. Sorry, so that's pretty much it. It's pretty straightforward, guys. I hope you understood it. You have to go a bit forward and aft, with the, not forward and aft, but a bit to and fro from the weather code and the solution here, as you can see. And if there is any kind of ice accretion, so again, this report didn't have ice accretion, and I was talking about ice accretion before. If there is any kind of ice accretion, so you have to go into the other relevant table. So in this example, we didn't have any ice accretion, but you can see here table number 19 gives you the type of ice accretion. If it's icing from sea spray, from fog, use the relevant codes. Rate of ice accretion, if ice is building up slowly, rapidly, concentration, arrangement of sea ice. So this is all for ice vessels. Alright, ice of land origin, stage of development, so on and so forth. So this is all for ice vessels. Again, continues into ice vessels here, bearing of principal age. So this report, the example that we took, didn't have any ice issues, but if it does have ice issues, or if you're on a ship with ice issues, or if you see these numbers going on in a question in the exam, that pretty much means that you have to now go into the ice section and decipher the report accordingly. So I hope this video was useful, guys. Let me know what you think about these videos. I'm just trying to do a good job here and try to help you out. If you feel that my knowledge is not enough, or I am not knowledgeable enough, or these videos are not helping, just don't watch my videos. But there is no need for any kind of negative or any attacking messages, as I have been getting from a couple of you. Most of you have been very appreciative. Thanks, guys.